Welcome to the online lecture series of refrigeration and air conditioning. Here is Professor Lakshman Mane. This is a video session on vapor compression refrigeration system, that is vapor compression cycle. In this session, you will be able to explain vapor compression refrigeration system, its components and working, vapor compression cycle, and performance of refrigeration system. Low temperature applications such as domestic refrigerator, water cooler, air conditioners, automobile car air conditioner, cold storage, ice plant, and central air conditioning systems. In all these applications, temperature inside the closed space is maintained below the surrounding temperature. How it is possible? So it is possible by using refrigerant, which is a two-phase substance. So this refrigerant is absorbing heat from the space to be cooled, which is kept at low temperature, and this heat is rejected to the surrounding, which is at high temperature. Now this is a mechanical system which is called as vapor compression refrigeration system. So let us study vapor compression refrigeration system. Major components of vapor compression refrigeration system are compressor, condenser, metering device or expansion device, and evaporator. Now in this system there are two parts. One is on high pressure side and one is on low pressure side. So this is done by the compressor. Evaporator is on low pressure side and condenser is on high pressure side. Compressors are various types of. Here is one of the compressor is reciprocating compressor, which is used in case of low temperature refrigeration applications, having tonnage capacity 5 to 10 TR and high pressure ratio. Screw compressor is a rotary type displacement type compressor which is used in process industries. Centrifugal compressor is used in air conditioning applications where high flow rate and low pressure ratio is required. Scroll compressor is rotary positive displacement type compressor which is used in air conditioning applications. Condenser is a device which is used to reject the heat from the refrigerant to the atmosphere. So here is a plate, fin and tube type condenser, in which these are the tubes which are surrounded by plate fins in order to increase the heat transfer area. Such kind of condensers are used in window split air conditioner. In this case, forced convection heat transfer is used. Means in this case, fan is provided below the tubes in order to increase the heat transfer. This is wire and tube type condenser which is used in domestic refrigerator and water cooler, in which natural convection heat transfer is used. Means in this case, fan is absent. Expansion valve is used to decrease the temperature and pressure of the liquid refrigerant. So this is a thermostatic expansion valve which is used in ice plant and chiller. This is a capillary tube which is used in domestic refrigerator and water cooler. Evaporator is used to absorb heat from the space to be cooled. So here is a plate surface evaporator which is used in refrigerator, display cooler, deep freezer, etc. This is another type of evaporator, that is direct expansion fin and tube type, which is used in air conditioners. In this case, this is a tube which is surrounded by the fins in order to increase the heat transfer rate. So here, as the refrigerant is passing through the tube in forward direction, by absorbing heat from the space to be cooled, this refrigerant is converted into vapor. So at the end of tube, complete vaporization of the refrigerant is possible by using direct expansion fin type tube evaporator. Now, working of vapor compression refrigeration system. In this case, at the evaporator, refrigerant at low pressure and low temperature is coming from the metering device. This refrigerant is compressed in a compressor in order to increase its thermal energy level. So compressor increases temperature and pressure of vapor refrigerant. So here this is a high pressure and high temperature vapor, which is passing now to the condenser. So condenser rejects heat from the vapor refrigerant to the atmosphere at constant pressure. So in this case, condensation of the refrigerant is taking place, means refrigerant is converted into liquid at constant pressure. Now this high pressure liquid refrigerant is coming to the next component, that is metering or expansion valve. In this case, this is a capillary tube like structure. So here, as the refrigerant is passing through small diameter tube, high resistance is offered to the refrigerant by the tube surface. Thus, temperature and pressure of the refrigerant, liquid refrigerant, are reduced a lot. Now, this process is a throttling process, means in this case there is no heat exchange between the system and surrounding, so enthalpy remains constant. So here, after the expansion, temperature of the refrigerant is going below 0 degrees Celsius because of low boiling point of the refrigerant. Such cold and low pressure refrigerant now is coming to the evaporator. So here, this low temperature and low pressure liquid refrigerant is absorbing heat from the space which is in the evaporator, and thus it is converted into vapor. So cooling effect is produced at the desired space in the evaporator, and the cycle is completed here. Now these cycles are continued till the temperature at desired space is reaching to the desired value. So in this way, working of vapor compression refrigeration system is taking place by using these 4 components. Now we will see its analysis of vapor compression refrigeration system. So for that purpose, we need pH diagram of refrigerant. So pH diagram means pH chart, which is a graphical representation of various properties like enthalpy, pressure, specific volume, specific entropy, temperature, density, etc. So here as a sample we are taking refrigerant chart of 134A, that is tetrafluoroethane, which is used in domestic refrigerator. So about this chart we can see different type of lines here. So here this is called as saturated curve of the refrigerant. So this is a left side line, that is called as saturated liquid line. It means all the points on this line are having pure liquid refrigerant, 100% liquid. This is right side line, that is called as saturated vapor line, means particles or points lying on this line will have 100% vapor, means pure vapor. Where these two lines are meeting this point, that is called as critical point. So at this point here is a corresponding temperature, that is critical temperature, and corresponding pressure, that is called as critical pressure. The importance of this point is what? It is not possible to liquefy the refrigerant above this point. Above this point, if the condenser line goes, then it is not possible to liquefy the refrigerant. So that is the limit of critical point. Now, because of this saturated curve, this total area is divided into three parts. So left side part is subcooled region. Inside this curve, the region is mixed, that is vapor plus liquid. That's why it is called as wet region. Right hand side region is of superheated vapor, that is superheated region. The one of the line of pressure, that is horizontal line, constant pressure. Vertical line which represents enthalpy, that is constant enthalpy. This is a temperature line which is vertical in subcooled region. In wet region it becomes horizontal, and in superheated region this line is falling in a downward direction in curved manner. This is a line which is emerging in inclined fashion going upward direction from the saturated vapor line. This is constant entropy line. This is a curved line which is having low slope than the entropy line. This is a density line. Some chart this line is shown as a specific volume line. So in this way all these lines are representing the pH diagram or pH chart of refrigerant. So by using this chart now we can plot the cycle of the vapor compression refrigeration system, that is called as vapor compression cycle. So here this is vertical axis of pressure in a bar or megapascal. Horizontal axis is of specific enthalpy in kilojoule per kg. This is saturated curve. Now here we will have two pressure lines. This is evaporator pressure line which is at lower side, condenser pressure line which is at higher side. Now we will see processes. Vapor compression cycle has 4 processes. So we will start from the point number 1. So we will consider this vapor compression cycle as a simple. That's why this cycle is called as simple saturation vapor compression cycle. Means in this case state of refrigerant at the suction of compressor is dry. So that's why this is the initial point which is lying on the saturated vapor line. That is point number 1. Now from 1 to 2 this process is taking place in the compressor. This compression process is isentropic process, means entropy is constant. Then 2 point is going in superheated zone. So now 2 to next point condensation take place. Now this condensation is having 2 parts. From this point number 2 to this point number 3, this is a total condensation process. But out of that, this 2 to this point, this is a desuperating. Okay, and after that this is latent heat removal process. So 2 to 3 condensation process take place condenser. Here heat is rejected to the atmosphere by the refrigerant at constant pressure. From point number 3 to point number 4 process take place, that is expansion. Now this is a throttling process, means in this case enthalpy of the refrigerant is constant. In this case temperature and pressure of the refrigerant are reduced a lot. This negative temperature. Now 4 to 1 process that is taking place in evaporator, means evaporation process. In this case liquid cold refrigerant is absorbing heat from the space to be cooled Thus enthalpy of this refrigerant is increasing from point number 4 to point number 1. So this is what evaporation process, which is taking place at constant pressure. Now this 2 dash, this is a point on the vapor line. So 2 to 2 dash is a degree of desuperheat. So here desuperheating is taking place. Performance of refrigeration system is indicated by some parameters. First parameter is refrigerating effect. So for that, here this is a process, that is evaporation process. During this process, heat is absorbed by the refrigerant from the cooled space. That's why enthalpy of refrigerant is increasing from point number 4 to point number 1. So that's why this is a cooling effect produced. So this cooling effect is given by refrigerating effect formula, that is H1 enthalpy minus H4 enthalpy in kilojoule per kg. Then 1 to 2 is a compression process. In this, compressor does work on the refrigerator. So work done by the compressor during 1 to 2 process is given as W is equal to enthalpy H2 minus enthalpy H1 in kilojoule per kg. Now, performance of refrigeration system, that is coefficient of performance, which is a ratio of desired effect divided by input. So desired effect means cooling effect, that is refrigerant effect, and input is compressor work. So that is why COP is what? Ratio of refrigerating effect divided by work. So here in the enthalpy form, COP is equal to H1 minus H4 divided by H2 minus H1. So at the end of this session, you can explain vapor compression refrigeration system, its components and working, vapor compression cycle and performance of refrigeration system. If you like this video, please subscribe and share. Thank you.